Tonight, you're going to look at something you've probably seen before and realize you never truly understood it. That faint, blurry patch in the night sky, the one most people mistake for a cloud, is not just distant. It's not just large. It's something far beyond what the human mind was ever built to grasp. And once you truly understand what you're looking at, it becomes impossible to see the universe the same way again. Because what you call Andromeda is not what's actually there. What your eyes detect is only the smallest, brightest fragment of something far larger. Something stretching across space in ways your vision simply cannot capture. In fact, most of Andromeda is completely invisible to you, even on the darkest night. And here's where the mystery deepens. The light entering your eyes right now, if you were looking at it, did not begin its journey recently. It left Andromeda long before modern humans existed, before cities, before language as we know it. You are not seeing Andromeda as it is, you are seeing it as it was. And that raises a quiet, unsettling question. If what we see is already millions of years out of date, what is Andromeda like now? Here on Valoran's Sleepy Space Mysteries, we explored something similar in our journey through the true scale of the Milky Way, where even our own galaxy turned out to be far stranger than expected. But tonight, we're stepping beyond it, into something even more overwhelming. So, if you enjoy slow, mind-expanding journeys through the cosmos, consider subscribing, leaving a like, and turning on the bell. And if you'd like to go deeper, you can join as a member to support the channel. And before we continue, tell me in the comments, where in the world are you watching from tonight? To truly understand Andromeda, we need to let go of the way we normally think about distance, because the numbers alone don't help. Saying that Andromeda is about 2.5 million light-years away sounds impressive, but it doesn't feel real. It doesn't connect to anything in your everyday experience. So instead of thinking in numbers, let's slow everything down and turn that distance into something you can almost feel. Imagine light itself, the fastest thing in the universe, moving at about 300,000 kilometers every second. That's fast enough to circle the Earth more than 7 times in a single second. Even at that incredible speed, light from the sun still takes over 8 minutes to reach you. So even sunlight is slightly delayed. You are always seeing the sun as it was 8 minutes ago. Now extend that idea outward. The nearest star beyond our sun is so far away that its light takes more than 4 years to reach us. Not seconds, not minutes, years. That alone is already difficult to fully grasp. But Andromeda exists on an entirely different scale. When you look at Andromeda, you are seeing light that has been traveling for 2.5 million years. That means the photons entering your eyes began their journey before modern humans existed in their current form. Before civilizations, before history, before anything you would recognize as human culture. And yet, somehow that ancient light arrives here, gently, quietly, appearing as nothing more than a faint blur in the sky. This creates a strange kind of disconnect. Something unimaginably vast and ancient is reduced to something so small and subtle that most people would never notice it at all. And this is where the illusion begins. Because your eyes are not designed to see reality at that scale. They show you only the brightest central region of Andromeda. a tiny fraction of its true size. It's like standing on a distant hill, looking at a massive city at night, and only seeing a few lights in the center, completely unaware of the sprawling landscape beyond. In reality, Andromeda stretches far beyond that faint glow. If your eyes were sensitive enough, you would see it spanning a huge portion of the sky, far larger than the moon. Not just a small patch, but something that would dominate your entire view of the night. But you don't see that, and that limitation quietly shapes your understanding. Now let's take this one step further. Even if you could travel at the speed of light, the absolute maximum speed allowed by physics, reaching Andromeda would still take 2.5 million years. That means if a journey began at the dawn of early human ancestors, it would only be arriving today. And of course, we are nowhere near that speed. The fastest spacecraft ever built by humanity moves incredibly fast by our standards, but compared to the scale of the universe, it is almost motionless. At that speed, a journey to Andromeda would take billions of years. Longer than Earth has even existed in its current form. So when we say Andromeda is our neighboring galaxy, it sounds close, familiar, almost reachable. But in reality, it exists at a distance so extreme that even imagining the journey begins to stretch the limits of thought. And yet, despite this unimaginable separation, there is something quietly happening. Andromeda is moving toward us, slowly, steadily, across the darkness of space. This massive galaxy is drifting closer to the Milky Way. You cannot see the motion, you cannot feel it, but it is happening right now. Which leads to another question, one that we will return to later. If something this distant, this massive, is already on its way toward us, what will happen when it finally arrives? For now, just let that thought settle in the background as we continue to unfold the true scale of Andromeda. Not just in distance, but in size, structure, and the hidden forces that hold it together. Now that you've begun to feel the distance to Andromeda, we can take the next step. Because distance alone is only half of the illusion. The other half is size. And this is where the quiet blur in the sky begins to transform into something far more overwhelming. When people first learn about galaxies, they often imagine them as large collections of stars, maybe bigger than our solar system, maybe even bigger than a cluster of stars. But Andromeda is not just large. It is vast in a way that reshapes your entire sense of scale. If you could somehow travel from one edge of Andromeda to the other at the speed of light, it would take over 200,000 years just to cross it. Not reach it, just cross it. That means even light itself, moving as fast as anything possibly can, needs longer than the entire span of human civilization just to move from one side of this galaxy to the other. And within that enormous structure, there are not millions of stars, but around 1 trillion. That number is so large that it stops behaving like a number. It becomes something abstract, something your mind cannot easily hold. So instead, imagine this slowly. If you started counting stars in Andromeda one by one, saying one number every second, never stopping to sleep, eat, or rest, it would take you tens of thousands of years just to finish counting them all. Entire civilizations would rise and fall before you reached the final number. And each of those stars is not just a point of light. Each one could have planets, moons, worlds, possibly entire systems as complex as our own, or even more so. So when you look at Andromeda, you are not looking at a single object. You are looking at a vast ocean of systems, each one with its own story, its own history, unfolding silently across time. But here's where something subtle happens. Even though Andromeda is larger than our Milky Way, even though it contains more stars, and even though it stretches across an unimaginable distance, it still appears small in our sky. Just a faint oval, easy to overlook. Why? Because distance compresses reality. The farther something is, the more its true scale collapses into something tiny from our perspective. Andromeda is a perfect example of this cosmic compression. Something enormous is reduced to something barely visible. And this leads to a deeper realization. What you see is not what exists. It is only what reaches you. Most of Andromeda's structure, its outer regions, its extended halo of stars, its faint streams left behind by ancient collisions, all of that is effectively invisible to your eyes. Even many telescopes struggle to capture its full extent. In reality, Andromeda extends far beyond its bright core, surrounded by a vast halo that stretches hundreds of thousands of light years into space. If your vision could reveal it fully, the night sky would look completely different. Instead of isolated stars, you would see an enormous, glowing structure spanning a significant portion of the sky. And yet, because most of it is too faint, it remains hidden. Not because it isn't there, but because we are limited. This is the second illusion. The universe is not only vast, it is selectively visible. Now, let's return to something we touched on earlier, something that quietly connects distance and size in a way that feels almost unsettling. The light from Andromeda is old, millions of years old, but the galaxy itself has not been standing still during that time. While that light was traveling toward us, Andromeda continued to evolve. Stars were born, others died, entire regions changed. Subtle gravitational shifts reshaped its structure. And all of that is happening beyond what we can currently see. So what you observe is not just distant, it is outdated. You are always looking into the past. And that raises a question that becomes harder to ignore the longer you think about it. If Andromeda has been changing for millions of years while its light travels toward us, then how different is it right now compared to what we see? Is it brighter, dimmer, more active, or quieter? Has something dramatic already happened there? Something we simply haven't seen yet? This is where Andromeda begins to shift from being just a distant galaxy into something more mysterious, something that exists partly beyond our awareness. And as we move deeper into its structure, into its core, its stars, and the forces that shape it, we'll begin to uncover just how dynamic and how alive this galaxy truly is. As we continue to move deeper into the scale of Andromeda, something subtle begins to shift in the way we think about reality itself, because distance and size are not just physical properties. They change how time behaves from our perspective. And this is where Andromeda becomes more than just a distant galaxy. It becomes a kind of time machine, quietly showing us a version of the universe that no longer exists. When you look at Andromeda, you are not observing a single moment. You are observing layers of time compressed into a single image. The light from its outer regions may have taken slightly longer to reach you than the light from its nearer edges. The stars within it are at different distances from Earth, meaning each one is sending you a slightly different version of the past. So even in a single glance, you are seeing a mixture of moments, all arriving together. It's not a snapshot. It's a blend of histories, and once you begin to see it that way, the quiet blur in the sky starts to feel less like an object and more like a story unfolding across millions of years. Now, let's return to the idea of structure, because understanding how something this vast holds itself together reveals another layer of the mystery. A trillion stars are not just floating randomly through space. They are bound together by gravity, moving in vast, slow patterns that take hundreds of millions of years to complete. Imagine a single star orbiting the center of Andromeda. That journey, one full orbit, can take hundreds of millions of years. Longer than dinosaurs existed on Earth. Longer than most complex life has existed at all. And yet, these motions are constant, ongoing, shaping the galaxy in ways that are almost impossible to perceive in real time. From our perspective, everything appears still, calm, unchanging. But in reality, Andromeda is in motion everywhere, all at once. Stars are drifting through its spiral arms. Gas clouds are collapsing to form new stars. Old stars are reaching the ends of their lives, expanding, fading, or exploding. And all of this is happening simultaneously across distances so large that no single observer could ever witness it all. This introduces another quiet realization. A galaxy is not a fixed structure. It is a process. Andromeda is not something that simply exists. It is something that is continuously happening. Now, think about how strange that is. When you look up at the night sky, it feels peaceful, almost timeless. But hidden within that calm appearance is an ongoing, dynamic system that is constantly changing, even if those changes are too slow for us to notice. And this brings us back to something we touched on earlier, the idea that Andromeda is moving toward us. This motion is not random. It is part of a larger gravitational relationship between galaxies. The Milky Way and Andromeda are the two largest members of what astronomers call the local group, a small collection of galaxies bound together by gravity. Over time, their mutual attraction has been pulling them closer and closer together. Right now, that motion is gentle, almost imperceptible, but it is steady. And if nothing interrupts it, in billions of years, these two massive galaxies will begin to interact in a way that will completely reshape both of them. But here's the part that feels almost impossible to accept. Even when that happens, even when two galaxies collide, the stars themselves will almost never crash into each other. Because space, even inside a galaxy, is mostly empty. The distances between stars are so vast that even during a massive galactic merger, most stars will pass by each other without direct contact. Instead, what changes is the structure, the gravitational balance, the paths that stars follow. Galaxies don't collide like solid objects. They merge like slow-moving clouds, passing through each other, stretching, distorting, and eventually settling into a new form. So when Andromeda finally reaches the Milky Way, it won't be a sudden event. It will be a long, gradual transformation, unfolding over hundreds of millions of years. And that idea quietly changes how we think about stability. Because something that looks permanent, something that seems fixed in the sky, is actually part of a much larger, ongoing evolution. Andromeda is not just distant. It is not just large. It is temporary. Not in the sense that it will disappear soon, but in the sense that it is always changing, always moving towards something else, always becoming something new. And as we continue, we'll begin to move inside that structure, into its core, its spiral arms, and the hidden forces that allow something so vast and so dynamic to remain together at all. As we move further into understanding Andromeda, something deeper begins to emerge, something that goes beyond distance, beyond size, and even beyond motion. It's the realization that everything we've described so far, every star, every orbit, every slow drift through space, is only the visible surface of a much larger system. Because the truth is, most of Andromeda isn't made of stars at all. In fact, the stars, as numerous as they are, make up only a small fraction of the galaxy's total mass. This is where the mystery quietly expands. If you were to measure how fast stars move within Andromeda, especially those far from its center, you would expect them to slow down as they get farther out. That's how gravity normally works. The farther you are from the main concentration of mass, the weaker the gravitational pull should be, and the slower objects should move. But that's not what we observe. Stars in the outer regions of Andromeda are moving much faster than they should be. Fast enough that, if only the visible matter existed, they should be flung out into intergalactic space. And yet, they remain bound to the galaxy, moving in stable orbits. Something is holding them there. Something invisible. This unseen presence is what we call dark matter, and it forms an enormous halo around Andromeda, extending far beyond the bright spiral structure you might imagine. While the visible galaxy spans a couple 100,000 light-years, the dark matter halo stretches several times farther, enveloping everything in a vast, silent sphere. And here's the strange part. We cannot see it. We cannot touch it. It does not emit light, reflect light, or interact with normal matter in any direct way we can easily detect. And yet, its gravitational influence dominates the galaxy. It is the hidden framework that holds Andromeda together. Without it, the galaxy as we know it simply could not exist. Now pause for a moment and let that settle in. Everything you can see in Andromeda, the trillion stars, the glowing spiral arms, the bright central core, that is only a small fraction of what's really there. Most of the galaxy is invisible. Most of its mass exists in a form we still do not fully understand. So when you picture Andromeda, you're only imagining the surface of something much larger and much stranger. And this introduces a new layer to the illusion. Not only is Andromeda distant, not only is it vast, but most of it is hidden. Now imagine what that means for the universe as a whole. If galaxies are built on structures we cannot see, if their true mass lies in something invisible, then our entire view of the cosmos is incomplete. We are observing only the parts that emit light, while the majority remains in darkness. And yet, that darkness is what shapes everything. It guides the motion of stars. It influences the formation of galaxies. It determines how structures grow and evolve over billions of years. In a way, dark matter is like a silent architect, building the universe from behind the scenes. Now, let's bring this back to Andromeda itself. Within this massive dark matter halo, the visible galaxy exists as a kind of luminous island. The stars form a disk, a flattened structure rotating slowly through space. At the center lies a dense region filled with older stars, and surrounding it are spiral arms where new stars are born. But even these structures are not fixed. The spiral arms are not solid, permanent features. They are more like waves moving through the galaxy, regions where stars and gas temporarily gather before spreading out again. A star might pass through a spiral arm, spend millions of years within it, and then drift out the other side, continuing its orbit around the center. So even the iconic shape of a galaxy is not static. It is a pattern, a flow, a constantly shifting arrangement of matter moving under the influence of gravity. And this brings us back to a question we've been quietly building toward. How does something so large, so dynamic, and so filled with motion remain stable over billions of years? Why doesn't it simply collapse inward or disperse outward? The answer lies in balance. Gravity pulls everything together, trying to collapse the galaxy inward. Motion pushes outward as stars move through space, resisting that collapse. And dark matter provides the additional gravitational structure needed to hold everything in place. It is a delicate equilibrium, not perfect, not unchanging, but stable enough to persist for billions of years. And yet, even this balance is not permanent, because as we've already begun to explore, Andromeda is not alone. It exists within a larger environment, interacting with smaller galaxies, absorbing them, reshaping itself over time, which means that even this massive, stable structure is slowly evolving, slowly transforming, moving toward a future that will look very different from what we see today. And as we move into the next part, we'll begin to explore that internal life in more detail, stepping inside Andromeda itself, into its core, its stars, and the processes that make this galaxy not just vast, but alive. As we reach the final stretch of this part, everything we've explored begins to come together into a single quiet realization that Andromeda is not just far away, not just enormous, and not just complex, but something that continuously challenges the limits of how we understand reality itself. Because when you combine distance, time, scale, and hidden structure, what you're really encountering is a system that exists far beyond direct human experience. Let's return for a moment to something simple, the act of looking. When you look at Andromeda, it feels immediate, present, as if it exists right there in front of you, suspended in the night sky. But now you know that this feeling is an illusion. What you're actually seeing is ancient light, traveling across an immense distance, carrying with it information from a time long before your own. So the experience of now becomes unreliable. You are always slightly out of sync with the universe. And this doesn't just apply to Andromeda. It applies to everything you see beyond your immediate surroundings. The farther away something is, the further back in time you are observing it. The universe, in this sense, is not just a place, it is a layered record of history. And Andromeda is one of the clearest examples of that. But here's where the thought deepens even further. While you are observing Andromeda as it was millions of years ago, Andromeda is also, in its own way, observing us. Not consciously, of course, but through the same physical process. Light from the Milky Way is traveling outward into space. Somewhere, far in the future, that light may reach observers in Andromeda, showing them a version of our galaxy from millions of years in the past. So there is a kind of symmetry here. Two galaxies, separated by vast distances, exchanging ancient versions of themselves through light, each one seeing the other not as it is, but as it was. It's a quiet, almost poetic connection. And yet, beneath that calm exchange, something much more dramatic is unfolding. Because these two galaxies are not just observing each other. They are moving toward each other. Slowly, steadily, across millions of years, Andromeda and the Milky Way are closing the distance between them. And while that motion is too slow for us to notice in a lifetime, it is inevitable on cosmic timescales. In about 4 to 5 billion years, they will begin to interact. At first, it will be subtle. Their outer regions will start to feel each other's gravitational pull. Stars will begin to shift slightly in their paths. Gas clouds will stretch and distort. Over time, these small changes will grow into something much larger. The two galaxies will pass through each other, not as solid objects but as vast, diffuse systems. Their structures will warp. Their spiral arms will stretch into long streams, and new waves of star formation will ignite as gas clouds collide and compress. The night sky, if anyone were there to see it, would become something almost unimaginable. Entire regions of stars would shift position. New patterns would form. The familiar structure of both galaxies would dissolve into something new. And eventually, after multiple passes and billions of years of interaction, the two galaxies will merge into a single larger galaxy. A new structure born from the combination of both. Sometimes this future galaxy is imagined as a giant elliptical galaxy, a smoother, less structured system compared to the graceful spirals we see today. And when that happens, something profound will have occurred. Everything that currently defines Andromeda as Andromeda, and the Milky Way as the Milky Way will be gone, replaced by something new. Which brings us to a final thought for this part. What we see in the night sky feels permanent, stable, unchanging. But in reality, everything is in motion. Everything is evolving. Even the largest structures in the universe are temporary when viewed over long enough timescales. Andromeda, as it exists today, is just one moment in a much longer story. A story shaped by gravity, time, and the quiet interactions of matter across unimaginable distances. And as we move into the next part, we'll step inside that story more closely, exploring the inner life of Andromeda, from its dense core to its spiral arms, and the processes that make this galaxy not just a structure in space, but a living, evolving system. And before we drift forward into that deeper journey, if you're still here, still listening, still letting these ideas unfold in your mind, gently leave a 1 in the comments. Just a quiet signal that you're still traveling through the universe with me. As we move inside Andromeda, leaving behind the overwhelming distances and entering the galaxy itself, the experience begins to change. It's no longer just about scale. It becomes about density, motion, and the strange environments that exist within this vast structure. Because while Andromeda may appear calm from afar, its interior is anything but quiet. At the very center of the galaxy lies a region so dense with stars that the night sky, if you could stand there, would be almost unrecognizable. Instead of a dark sky scattered with distant points of light, you would see thousands of stars shining brightly in every direction, many of them so close and luminous that they would cast shadows. Darkness, as we know it, would barely exist. This central region, often called the galactic bulge, is packed with some of the oldest stars in Andromeda. These stars formed billions of years ago, when the galaxy was still young, and they have remained there ever since, orbiting the center in complex, overlapping paths. Unlike the orderly rotation of the outer disk, the motion here is more chaotic, with stars moving in many different directions, crossing paths over immense timescales. And at the very heart of this dense stellar environment lies something even more extreme, a supermassive black hole. This object contains a mass tens of millions of times greater than our Sun, compressed into a region so small that not even light can escape from it. It does not shine, it does not glow, and yet its presence dominates the center of the galaxy, shaping the motion of everything around it. Now, despite its reputation, this black hole is not constantly consuming matter. In fact, for long periods of time, it can remain relatively quiet, with only small amounts of gas drifting inward. But when something does fall too close, the results can be dramatic. The material heats up, accelerates, and emits intense radiation before disappearing beyond the boundary we call the event horizon. These moments are rare, but they remind us that even in a region that appears stable, there are processes unfolding that are incredibly energetic. And yet, the black hole itself is only part of the story. The real transformation happens when you consider how stars behave in such a crowded environment. In most regions of a galaxy, stars are separated by vast distances, making close encounters extremely rare. But near the core of Andromeda, the distances shrink. Not enough for stars to collide directly, but enough for their gravitational influence on each other to become significant. Stars can pass relatively close to one another, altering their paths. Binary systems can be disrupted, with one star captured into a new orbit while another is flung outward at high speed. Over millions of years, these interactions reshape the distribution of stars, creating a dynamic and ever-changing environment. And occasionally, a star may wander too close to the central black hole. When that happens, the star is not simply pulled in. It is stretched, distorted, and torn apart by intense gravitational forces in an event known as a tidal disruption. The star's material is pulled into a long stream, wrapping around the black hole, heating up, and emitting powerful radiation before finally disappearing. It is a violent process, but also a rare one, unfolding quietly over vast stretches of time. Now, as we move outward from the core, something begins to change again. The density of stars decreases. The chaotic motion gives way to more organized patterns. And we begin to enter the region that gives Andromeda its iconic shape. The disk. This is where the spiral arms exist, where stars, gas, and dust form a flattened structure rotating around the center. Compared to the crowded core, this region feels almost spacious. Stars are separated by greater distances, and their motion follows more predictable paths. But even here, things are not as simple as they appear, because the spiral arms are not fixed structures. They are not permanent formations made of the same stars. Instead, they are more like waves moving through the galaxy, regions where stars and gas temporarily gather, slow down, and then move on. A star might spend part of its life inside a spiral arm, surrounded by newly forming stars and glowing clouds of gas, and then gradually drift away as it continues its orbit. This means that the beautiful spiral pattern we imagine is not static. It is constantly forming, dissolving, and reforming over time. And within these arms, something remarkable is happening. New stars are being born. Cold clouds of gas collapse under their own gravity, forming dense regions that eventually ignite nuclear fusion, giving birth to new stars. Some of these stars will be small and long-lived, shining quietly for billions or even trillions of years. Others will be massive, bright, and short-lived, burning intensely before ending their lives in powerful explosions. So even as older stars age and fade, new ones are constantly emerging. The galaxy is renewing itself, and this is where Andromeda begins to feel less like a static object and more like a living system, a place where cycles of creation and destruction are always unfolding, quietly, steadily, across millions of years. And as we continue, we'll move deeper into these processes, exploring how stars live and die within Andromeda, and how those cycles shape the galaxy over time. As we continue deeper into Andromeda's inner life, the story becomes less about where things are, and more about how they change. Because inside this galaxy, nothing is permanent. Every star you imagine, every glowing region, every quiet point of light is part of a long cycle that begins in darkness and eventually returns to it. Let's begin with the birth of a star. Hidden within Andromeda's spiral arms are enormous clouds of gas and dust, so vast that they can span hundreds of light years. These clouds are cold, dark, and almost completely invisible in ordinary light. If you could pass through one, you wouldn't see a glowing nebula like in photographs. You would drift through darkness, surrounded by thin gas and microscopic particles, barely noticing anything at all. And yet, within that darkness, something begins. Over time, small regions inside these clouds start to gather more material. Gravity slowly pulls gas inward, creating denser pockets. These pockets continue to grow, becoming warmer and more compact. It is a slow process, unfolding over hundreds of thousands of years, almost silent, almost invisible. Then, at a certain point, something changes. The temperature at the center rises high enough for nuclear fusion to begin. hydrogen atoms start to combine, releasing energy. And just like that, a star is born. A new source of light appears where there was once only darkness. But not all stars are the same, and this is where the story branches into different paths. The mass of a star at its birth determines everything about its future. Small stars, much less massive than our sun, burn their fuel slowly and steadily. They can live for trillions of years, far longer than the current age of the universe. In Andromeda, these small stars are incredibly common, quietly glowing for unimaginable spans of time. Larger stars live very different lives. A star with several times the mass of the sun burns brighter, hotter, and much faster. It may shine intensely for millions of years, flooding its surroundings with energy. But this brilliance comes at a cost. It uses up its fuel quickly, and when that fuel runs out, the ending is far more dramatic. The star expands, becomes unstable, and eventually collapses under its own gravity. In many cases, this collapse triggers a powerful explosion, a supernova. For a brief moment, that single star can outshine an entire galaxy. The explosion sends material rushing outward at incredible speeds, scattering heavy elements into the surrounding space. Elements like carbon, oxygen, iron, the very materials that make up planets, and even life itself. So in a quiet and indirect way, these distant explosions are connected to everything you are. The atoms in your body were once forged in stars like these. And inside Andromeda, this process is happening right now. Somewhere within its spiral arms, stars are being born. Others are aging. Some are reaching the ends of their lives. And occasionally, one is exploding, sending its material back into the galaxy, where it may one day become part of a new generation of stars. It is a continuous cycle: birth, life, death, and rebirth. And this cycle slowly changes the galaxy over time. Each generation of stars enriches the surrounding gas with heavier elements. The earliest stars in Andromeda were made almost entirely of hydrogen and helium, the simplest elements formed after the beginning of the universe. But as stars lived and died, they added complexity to the galaxy. New stars formed from enriched material, capable of creating planets, moons, and more complex structures. So the Andromeda you see today is not the same as it was billions of years ago. It has evolved. Now, there is another layer to this story that adds even more complexity. Many stars do not exist alone. A large number of stars in Andromeda are part of binary systems, where two stars orbit each other. In some cases, these systems remain stable for billions of years. But in others, something more unusual happens. If one star evolves faster than its companion and becomes a dense remnant, like a white dwarf, it can begin to pull material from the other star. This process can continue quietly for a long time, until enough material accumulates. And then, suddenly, another explosion, a different kind of supernova, one that shines with remarkable consistency, so consistent that astronomers use these events as cosmic measuring tools, allowing us to determine distances across the universe. So even in their death, stars help us understand the cosmos. And as you begin to see all of this together, the quiet glow of Andromeda starts to feel very different. It is no longer just a distant object. It is a vast, ongoing process of transformation, filled with cycles that repeat over millions and billions of years. And yet, despite all this activity, it still appears calm from where we are. Still, silent, unchanging. But now you know the truth. Beneath that calm appearance lies a galaxy full of motion, full of change, full of events unfolding every moment across distances too vast to fully imagine. And as we continue, we'll explore the hidden forces that influence these processes, forces you cannot see directly, but that shape the behavior of everything inside Andromeda. As we continue exploring the inner workings of Andromeda, we begin to encounter forces that are far less visible than stars, yet just as important in shaping everything we see. Because between the stars, filling the vast spaces that might otherwise seem empty, there exists something subtle, a thin, almost ghost-like medium of gas, dust, magnetic fields, and high-energy particles. And while it may seem insignificant, this invisible environment plays a quiet but powerful role in the life of the galaxy. Imagine drifting through Andromeda not as a solid traveler, but as something sensitive enough to detect even the faintest traces of matter. You would find that space is not completely empty. Instead, it is filled with an extremely thin mixture of gas, mostly hydrogen, spread so sparsely that it would feel like nothing at all. And yet, across the immense scale of a galaxy, it adds up to an enormous amount of material. This is the interstellar medium, and it is the raw material from which new stars are born. But it is not uniform. Some regions are colder, denser, and darker, forming the massive molecular clouds we explored earlier. Other regions are warmer, more diffuse, shaped by radiation from nearby stars. And in certain places, the gas becomes ionized, glowing softly as it interacts with intense energy from young, hot stars. So even in the empty spaces, there is structure variation and quiet activity. Now, within this medium, something even more subtle exists. Magnetic fields. They are incredibly weak compared to what you experience on Earth, yet they stretch across the entire galaxy, threading through gas clouds, spiral arms, and the spaces between stars. You cannot see them directly, but they influence how charged particles move, how gas behaves, and even how stars form. Imagine these magnetic fields as invisible lines woven through Andromeda, gently guiding the motion of particles. When high-energy particles move through these fields, they spiral along them, tracing out paths that reveal the underlying structure. These particles are known as cosmic rays. They are tiny fragments of matter, often accelerated by violent events like supernova explosions. Once released, they travel through the galaxy at nearly the speed of light, carrying energy across vast distances. They do not move randomly. Instead, they follow the magnetic pathways, weaving through the galaxy in complex patterns. And while each individual particle is small, together they contribute energy and pressure to the interstellar medium, subtly influencing its behavior. So even in the quiet darkness between stars, there is motion, energy, and structure. Now let's return to something more visible, but equally complex. Nebulae. These are the glowing clouds often captured in images of galaxies, and Andromeda contains thousands of them. But they are not all the same. Each type tells a different part of the galaxy's story. Some nebulae are regions where new stars are forming. These are filled with ionized gas, glowing softly as young stars flood their surroundings with radiation. Others are the remains of dying stars, shells of gas expanding outward after being expelled into space. And some are simply clouds of dust reflecting the light of nearby stars, appearing faint and blue in contrast to the darker regions around them. There are also dark nebulae, regions so dense with dust that they block light entirely, appearing as shadows against the brighter background. These are often the places where future stars will form, quiet regions where gravity is slowly gathering material for the next generation. So across Andromeda, there is a constant transformation happening within these clouds. Some are giving birth to stars. Others are marking the end of stellar lives. And many are simply waiting, slowly evolving over time. Now, step back for a moment and consider what this means. A galaxy is not just made of stars. It is an ecosystem. Gas becomes stars. Stars create energy and heavier elements. Some of that material is returned to space, enriching the gas. And that enriched gas forms new stars, continuing the cycle. Everything is connected, and yet all of this unfolds so slowly, so gently, that from our distant perspective, it appears almost completely still. But there is one more layer to this hidden structure, something that extends far beyond the visible disk of Andromeda, a vast halo. This halo surrounds the galaxy, stretching hundreds of thousands of light years into space. It contains old stars, remnants of smaller galaxies that were torn apart and absorbed over billions of years. It also contains gas, both cold and hot, drifting through this extended region. If you were somehow placed in this outer halo, far from the bright core, the sky would look very different. The dense star fields would fade away, leaving only a sparse scattering of distant stars, while the glowing center of Andromeda would dominate one part of the sky, shining as a massive, distant structure. It would feel isolated, quiet, almost empty, and yet, even here, the story continues, because this halo is not just a passive boundary. It is a record of Andromeda's past. Streams of stars trace the paths of galaxies that were pulled apart long ago. Subtle patterns reveal ancient collisions, interactions that shaped the galaxy into what it is today. So when you look at Andromeda, you are not just seeing a galaxy. You are seeing the result of billions of years of history, written not in words, but in the distribution of stars, gas, and invisible forces. And as we continue, we will begin to uncover that history more clearly, exploring how Andromeda grew, how it consumed other galaxies, and how those ancient events still shape it today. As we continue drifting through Andromeda, we begin to uncover a quieter, more ancient story, one that is not written in bright stars or glowing nebulae, but in faint traces scattered across the outer regions of the galaxy. Because beyond the visible structure, Beyond the spiral arms and the luminous core, Andromeda carries the memory of everything it has ever consumed. This is where the idea of a galaxy as a living system becomes even more profound. Andromeda did not form in isolation. It grew over billions of years, slowly gathering matter from its surroundings. Smaller galaxies drifted too close, caught by its gravity, and over time, they were pulled apart, stretched, and eventually absorbed. But this process is not violent in the way we might imagine. It is slow, quiet, unfolding across immense stretches of time. When a smaller galaxy approaches Andromeda, tidal forces begin to act on it. The side closer to Andromeda feels a stronger pull than the far side, and this difference begins to stretch the smaller galaxy. At first, the effect is subtle. The shape becomes slightly distorted, but as it moves closer, the stretching becomes more pronounced. Eventually, the structure of the smaller galaxy cannot hold together. Its stars begin to drift away, forming long, thin streams that trace its original orbit. These streams can stretch across tens or even hundreds of thousands of light years, wrapping around Andromeda like faint ribbons. Over time, they spread out further, becoming more diffuse until they blend into the halo. But they do not disappear completely. If you look closely enough, if you map the positions and motions of stars with great precision, you can still see these patterns. You can still trace the paths of galaxies that no longer exist as separate objects. In this way, Andromeda's halo becomes a kind of archive, a record of past encounters, preserved in the distribution of stars. Each stream tells a story, a galaxy that once existed on its own, with its own stars, its own structure, its own history, now stretched and absorbed into something larger. And this process is not finished. Even now, Andromeda continues to interact with its satellite galaxies. Some are already being torn apart, their stars slowly drifting into the halo. Others remain intact for now, orbiting at a distance, but their future is already determined. Over billions of years, most of them will be absorbed as well. This gradual growth is sometimes described as galactic cannibalism. But unlike the word suggests, it is not a sudden act. It is a slow merging of structures, a blending of stars and matter, guided entirely by gravity. Now, among these satellite galaxies, a few stand out. Some are relatively large, containing billions of stars, while others are incredibly small, made up of only a few thousand stars scattered across space. These smaller systems are faint, difficult to detect, and often dominated by dark matter, meaning most of their mass is invisible. And this introduces another layer to the mystery, because when these small galaxies are absorbed, they do not just contribute stars. They also contribute dark matter, adding to the invisible halo that surrounds Andromeda. So the galaxy grows not only in visible structure, but also in hidden mass. Over time, this accumulation shapes the overall gravitational field of Andromeda, influencing how stars move, how gas flows, and how future interactions will unfold. Now, let's step back and imagine this process over billions of years. Andromeda begins as a smaller structure in the early universe. Gradually, it attracts gas and forms stars. It interacts with nearby systems, merging with some, absorbing others. Each interaction leaves behind subtle traces, streams of stars, distortions in structure, shifts in motion. Slowly, it becomes larger, more complex, more massive, and all of this happens without any clear boundary between events. There is no single moment where Andromeda becomes what it is today. Instead, it is always becoming, always evolving. And this leads to a realization that connects everything we've explored so far. When you look at Andromeda, you are not seeing a finished object. You are seeing a moment in an ongoing process, a structure that has been shaped by countless interactions, many of which are still visible if you know how to look. And yet, from our distant perspective, all of that complexity is hidden within a soft, faint glow. Now, as we prepare to move into the next segment, there is one more idea to hold on to. The outer regions of Andromeda, the halo, the streams, the satellite galaxies. These are not just details. They are clues. They tell us how galaxies grow, how they interact, and how structure forms across the universe. Because Andromeda is not unique in this process. Every large galaxy you can imagine has a similar story, a history of mergers, interactions, and gradual growth. And by studying Andromeda, we are also learning about the broader behavior of the universe itself. A universe where structures are not fixed, but built slowly over time. And in the next segment, we'll bring all of these ideas together, exploring how gravity, motion, and hidden mass combine to maintain this delicate balance, and how that balance will eventually lead to one of the most extraordinary events in our cosmic future. As we reach the final layer of Andromeda's inner structure, everything we've explored begins to connect into a single, quiet system of balance. A balance so vast and so precise that it allows this galaxy to exist for billions of years without collapsing or tearing itself apart. Because beneath the beauty of spiral arms, beneath the birth and death of stars, beneath even the invisible presence of dark matter, there is one force guiding it all. Gravity, but not gravity as you experience it on Earth. Not the simple pull that keeps you grounded. This is gravity operating on a scale so immense that it shapes entire systems, holding together trillions of stars across distances that stretch beyond comprehension. Now imagine Andromeda not as a collection of individual objects, but as a single gravitational system. Every star, every cloud of gas, every particle of dark matter is interacting with everything else. Each one contributes to a vast gravitational field that extends far beyond the visible galaxy. At the center, gravity is strongest. Stars move quickly, pulled tightly into their orbits. As you move outward, the pull weakens slightly, but something unexpected happens. Instead of stars slowing down as you might expect, they continue moving at surprisingly high speeds. This brings us back to something we touched on earlier, the hidden mass of dark matter. Without that invisible halo, the outer regions of Andromeda would not remain stable. Stars would drift away, the structure would unravel, and the galaxy as we know it would not exist. But because of this hidden mass, the gravitational field extends much farther than the visible galaxy, creating a kind of invisible boundary that holds everything together. So what you are really seeing when you look at Andromeda is only the illuminated center of a much larger structure. A structure defined not just by what shines, but by what cannot be seen. Now, within this gravitational system, motion becomes the key to stability. Stars are not falling inward toward the center because they are already moving sideways, orbiting at high speeds. This motion creates a balance between inward pull and outward momentum. If a star were to slow down, it would begin to spiral inward. If it moved too fast, it could escape the galaxy entirely. So every star exists in a delicate balance, following a path shaped by both gravity and motion. And these paths are not perfect circles. Many stars follow elongated orbits, moving closer to the center and then drifting farther away again over time. Others oscillate above and below the galactic plane, creating a subtle thickness to the disk. Over millions of years, these motions create a complex, layered structure, one that is constantly shifting, even if the overall shape remains recognizable. Now, consider what happens when something disturbs this balance. A passing satellite galaxy, a dense cloud of gas, or even the slow accumulation of dark matter can subtly alter the gravitational field. These changes ripple outward, affecting the orbits of stars, reshaping regions of the galaxy over time. This is why Andromeda is not perfectly symmetrical. The spiral arms are slightly uneven. Its outer regions are warped. These are not flaws. They are signatures of past interactions, evidence that the galaxy has been shaped by external influences over billions of years. And yet, despite all of this complexity, the galaxy remains stable. Not static, but stable. Continues to rotate. Continues to form stars. Continues to evolve. And this brings us to a deeper realization. Stability in the universe does not mean stillness. It means balance within motion. Now, let's extend this idea even further. Andromeda is not isolated. It exists within a larger gravitational environment, influenced not only by its own mass, but by the presence of nearby galaxies, especially the Milky Way. These two massive systems are already affecting each other, even across millions of light years. Their dark matter halos may already be interacting, creating subtle distortions in their outer regions. Over time, these interactions will grow stronger. The balance that currently defines each galaxy individually will begin to shift into a new, shared system. And when that happens, everything we've described, the orbits, the structure, the delicate equilibrium will begin to change. Stars will be pulled into new paths. Gas will be compressed, triggering bursts of star formation. The spiral arms will stretch and dissolve. The identities of both galaxies will gradually fade as they merge into something entirely new. But even in that transformation, the same principles will apply. Gravity, motion, balance. These are the rules that shape everything, from the smallest star to the largest galaxy. And as we prepare to move into the final part of this journey, there is one last thought to carry with you. Everything you have imagined so far, the vast distances, the countless stars, the hidden structures, the slow evolution, all of it exists within a system that is still changing, still moving, still becoming something new. And in the next part, we will step beyond Andromeda itself, exploring the invisible structures that surround it, the future that awaits it, and what all of this reveals about our place in the universe. As we move beyond the visible structure of Andromeda, something begins to change in a very subtle way. Because the farther we drift from the bright core and spiral arms, the more the galaxy seems to fade. The stars become fewer, the light grows dimmer, and eventually, it feels as though we are leaving the galaxy behind. But we are not. In fact, we are only now beginning to see its true extent. Because what appears to be the edge of Andromeda is not an edge at all. It is simply the limit of what we can easily detect. Beyond that lies a vast, diffuse region that stretches far into space, so faint that it almost disappears into the darkness. This is the outer halo, and it is far larger than most people ever imagine. If you could step far enough away and somehow perceive everything at once, you would see that Andromeda is surrounded by an enormous spherical envelope. Not bright, not dense, but real. This halo extends hundreds of thousands of light years beyond the visible disk, making the galaxy far larger than it appears from Earth. And within this halo, there are stars, but they are scattered so sparsely that the sky would feel almost empty if you were there. The nearest stars might be separated by hundreds of light years, leaving vast regions of darkness between them. The bright, crowded beauty of the inner galaxy would be gone, replaced by a quiet, almost endless emptiness. But even here, the story continues, because this outer halo is not just made of stars. It is filled with gas, extremely hot, extremely diffuse gas, heated to temperatures so high that it emits energy not in visible light, but in X-rays. This gas forms a vast reservoir, surrounding the galaxy like a faint, invisible atmosphere. It is material that has been pushed outward by supernova explosions and energetic processes within the galaxy, slowly drifting through this extended region. And over time, some of this gas will cool and fall back inward. So even at the edges of Andromeda, there is a slow cycle of movement. Material flowing outward, then returning, feeding future generations of stars. Now let's take one step further. Beyond the stars, beyond the gas, beyond even the visible halo, lies something even more fundamental. The dark matter halo. This is the true boundary of Andromeda's influence, though it is not a sharp boundary at all. It is a vast, invisible structure, extending even farther than the halo of stars and gas. This dark matter does not shine, does not interact with light, and yet it contains most of the galaxy's mass. If you could see it, Andromeda would no longer appear as a bright spiral with a faint outer glow. It would appear as a massive, almost ghostly sphere, with the visible galaxy embedded deep within it like a glowing core. And this changes everything, because it means that the galaxy you see is only a small part of what actually exists. Most of Andromeda is hidden, shaping its behavior from the shadows. Now imagine drifting even farther out. At some point, the influence of Andromeda begins to overlap with something else. Another galaxy, the Milky Way. Although they are separated by millions of light years, their dark matter halos may already be touching, subtly interacting across the void. This interaction is incredibly weak at first, almost imperceptible, but it marks the beginning of a much larger process. Because galaxies are not isolated islands. They are part of a larger structure known as the cosmic web, a vast network of matter stretching across the universe. Along these filaments, gas flows slowly, feeding galaxies over time. Andromeda is connected to this web, continuously drawing in material, slowly growing, slowly evolving. So even at the largest scales, the galaxy is not alone. It is part of something bigger. And this leads to a realization that feels both quiet and profound. There is no true edge to Andromeda, only a gradual transition from what we can see to what we cannot, from light into darkness. And yet, that darkness is not empty. It is full of structure, full of influence, full of unseen mass shaping everything within it. As we continue, we'll move into the future of Andromeda, exploring what will happen as it continues to evolve, as it interacts more strongly with the Milky Way, and how this slow, inevitable process will reshape both galaxies into something entirely new. As we continue drifting outward, away from the visible glow of Andromeda and deeper into the quiet darkness that surrounds it, the story begins to shift toward the future. Because everything we've explored so far is not frozen in time. It is part of a slow, inevitable unfolding that has already begun, even if it is far too gradual for us to notice within a single lifetime. And at the center of that future is motion. Right now, at this very moment, Andromeda is moving toward us. Not in a dramatic or sudden way, but with a steady, quiet velocity, crossing the vast emptiness between galaxies. The distance is still immense, but it is shrinking slowly, year by year, century by century, across millions of years. If you could observe this motion over an extremely long period, you would see Andromeda gradually growing larger in the sky. At first, the change would be almost impossible to detect. But over millions of years, the faint blur would expand, becoming brighter, more detailed, more present. Eventually, it would no longer be a small patch in the sky. It would become something dominant. Now imagine standing on Earth billions of years in the future, looking up at the night sky. Andromeda would no longer appear distant. Its structure would begin to resolve, its spiral arms stretching across a large portion of the sky, glowing softly, slowly approaching. And then the interaction would begin, not as a sudden collision, but as a gradual gravitational dance. The outer regions of both galaxies would feel each other first. Their halos would overlap, and the delicate balance of gravitational forces would begin to shift. Stars at the edges would be gently pulled into new paths. Gas clouds would stretch, forming long, faint bridges between the two galaxies. Over time, these interactions would grow stronger. The galaxies would pass through each other for the first time, their structures distorting, their spiral arms stretching into long arcs. Enormous tidal forces would reshape both galaxies, pulling streams of stars far into space, creating vast, glowing trails that would linger for millions of years. And yet, as we mentioned before, the stars themselves would almost never collide. The distances between them are simply too great. Instead, the transformation happens on a larger scale. Orbits change, structures dissolve, patterns rearrange, Now, as these two galaxies continue to interact, something remarkable happens. New stars begin to form. As gas clouds from both galaxies collide and compress, they trigger intense bursts of star formation. Regions that were once quiet suddenly become filled with bright, young stars, illuminating the surrounding space. For a time, the combined system becomes more active, more luminous, more dynamic than either galaxy was on its own. It is a moment of creation, born from interaction. But it is also temporary, because over time, as the galaxies continue to merge, their structures begin to settle. The distinct spiral shapes fade. The long tidal streams gradually disperse. The chaotic motion slowly gives way to a new equilibrium. And eventually, a new galaxy emerges. No longer the Milky Way, no longer Andromeda, but something entirely different. A single, larger galaxy, likely more rounded, more diffuse, with less of the clear spiral structure we see today. A galaxy shaped by the combination of both, carrying the history of each within its stars. Now, pause for a moment and consider what this means. Everything that defines the night sky as we know it, the familiar band of the Milky Way, the distant glow of Andromeda, all of it will change. The sky will not remain as it is. It will evolve just like everything else in the universe. And yet, this transformation is not something to fear. It is simply part of the larger story. Because galaxies are not permanent structures. They are stages in an ongoing process, shaped by gravity, time, and interaction. Andromeda, as it exists today, is only one chapter. The future galaxy that will emerge from its merger with the Milky Way will be another. And beyond that, the story continues. Because even after this merger, the new galaxy will still exist within the cosmic web, still interacting with its surroundings, still evolving over billions of years. So there is no final state, only continuous change. Now, as we move closer to the end of this journey, one final idea begins to take shape. Everything we have explored, from the faint blur in the sky to the vast halo of dark matter, from the birth of stars to the merging of galaxies, all of it exists within a universe that is constantly unfolding, constantly moving, constantly becoming something new. And in the final segment, we will slow down and reflect on what all of this means, not just for Andromeda, but for us, for our place within this vast, ever-changing cosmos. As we begin to slow down and reflect, something subtle starts to shift in how Andromeda feels in your mind. It is no longer just a distant object, no longer just a collection of facts about distance, stars, or structure. It becomes something more continuous, something that exists across time in a way that quietly includes you within its story. Because everything we've explored is not separate from you. The light from Andromeda reaches your eyes. The atoms inside your body were once formed in stars, possibly in galaxies like it. The same physical laws that shape its motion shape everything around you. So even though it feels distant, there is a connection. Not obvious, not immediate, but real. Now imagine, just for a moment, removing distance from the picture. Imagine you could observe Andromeda not from millions of light years away, but from within it, drifting somewhere in its outer regions, looking toward its glowing core. the experience would be entirely different. Instead of a faint blur, you would see a vast structure stretching across the sky, filled with layers of light, dust, and motion. You would not perceive it as a single object. You would perceive it as an environment. Stars would move slowly over time. Clouds of gas would glow softly in the distance. Occasional bursts of light would mark the deaths of massive stars. And all of it would unfold so gradually that it would feel almost timeless. But even then, even within it, you would not see everything. Because much of Andromeda is invisible. The dark matter halo would remain hidden, even though it defines the galaxy's true size. The hot gas in the outer halo would be difficult to perceive. The subtle gravitational interactions shaping the galaxy's evolution would be impossible to see directly. So even from within, your understanding would still be incomplete. And this leads to a quiet realization. No matter where you are, no matter how close you get, there are always limits to what you can perceive. The universe is always larger than your ability to observe it. Now let that idea expand. If Andromeda, one galaxy among billions, contains structures we cannot fully see or understand, then what does that say about the universe as a whole? It suggests that what we observe is only a fraction of what exists, that beyond every visible structure, there are deeper layers, hidden processes, and unseen influences shaping everything. And yet, despite this, we are able to understand as much as we do. Through observation, through careful measurement, through patient exploration, we have begun to piece together a picture of something far larger than ourselves. Not complete, but meaningful. And Andromeda plays a special role in that understanding. It is close enough to study in detail, yet distant enough to represent something beyond our own galaxy. It acts as a bridge between what we know intimately and what lies farther out in the universe. By studying Andromeda, we learn about galaxies in general. We learn how they form, how they evolve, how they interact, and how they eventually change over time. But there is something else, something quieter, that Andromeda offers: perspective. Because when you truly begin to understand its scale, its distance, its age, your sense of place begins to shift. The concerns that feel large in everyday life start to feel smaller, not because they are unimportant, but because they exist within a much larger context. You begin to see yourself not as separate from the universe, but as part of it. A very small part, but still connected. And this connection is not just philosophical. It is physical. The same processes that shape galaxies also shape stars. The same processes that shape stars create the elements that form planets. And those elements eventually become part of living systems. So in a very real sense, the story of Andromeda is not entirely separate from your own. It is part of the same unfolding universe. Now, as we prepare to move into the final segment, let yourself settle into that idea. Let the vastness of it become something calm rather than overwhelming. Because the goal is not to fully comprehend something beyond comprehension. The goal is simply to experience it, to sit with the idea that somewhere, far beyond what you can see clearly, a galaxy is slowly evolving, slowly moving, slowly changing, just as it has for billions of years. And in the final moments of this journey, will gently bring everything together, not with answers, but with a quiet sense of perspective and a calm awareness of the universe that surrounds you. As we continue gently toward the end of this journey, the story of Andromeda begins to slow, not because the galaxy itself slows, but because our perspective begins to settle. We have moved from distance to structure to motion, and now what remains is something quieter, something that lingers in the background of everything we've explored. Time. Not the kind of time you measure with clocks or days or years, but cosmic time. The kind of time in which galaxies are born, grow, interact, and eventually transform into something else. The kind of time in which Andromeda has already lived for billions of years, and will continue for billions more. Now imagine rewinding that time. Imagine Andromeda long before it became the galaxy we see today. A younger universe, filled with smaller, less structured systems. Clouds of gas collapsing, early stars igniting, the first faint outlines of what would one day become a spiral galaxy beginning to take shape. There was no clear moment where Andromeda suddenly appeared. It emerged gradually. Gas gathered. Stars formed. Gravity shaped everything into a rotating structure. Smaller galaxies merged into it, adding their stars, their gas, their dark matter. Over time, the galaxy grew larger, more complex, more defined. And all of this happened slowly. So slowly that no single moment could capture the transformation. Now let that thought move forward again. Return to the present, to the Andromeda we observe today. A mature galaxy, still forming stars, but at a quieter pace. A system that has already passed through its most active periods, now settling into a more stable phase of its life. And then, continue forward, billions of years into the future, toward the moment we described earlier, when Andromeda and the Milky Way begin to merge. At that point, Andromeda will no longer be what it is now. Its structure will stretch, distort, and eventually dissolve into something new. And even after that, the story does not end. The new galaxy that forms will continue to evolve. Stars will continue to age. New stars will still form, though more slowly. The available gas will gradually be used up. Over immense spans of time, star formation will decline, and the galaxy will become quieter, dimmer, older. Eventually, far in the future, most stars will be long-lived, faint red stars. Bright, massive stars will be rare. The galaxy will glow more softly, its dynamic past giving way to a calmer, slower existence. And if we extend this even further, into timescales so vast they are difficult to imagine, even those stars will begin to fade. Not suddenly, but gradually. The universe itself will continue to change, expanding, cooling, evolving. And Andromeda, or whatever it becomes, will be part of that larger transformation. Now return to the present one last time. Look again in your mind at that faint patch in the sky. The one that started this journey. The one that seemed so small, so simple, so easy to overlook. And now, after everything you've explored, notice how different it feels. It is no longer just a blur. It is a vast, evolving system, a structure shaped by gravity and time. A place where stars are born, where others die, where invisible forces guide motion, where entire galaxies are slowly absorbed, and where a future transformation is already on its way. And yet, from here, it remains quiet, still, almost peaceful. And maybe that is the most remarkable part of all, that something so vast, so active, so complex, can appear so calm from a distance. So as we come to the final moments of this journey, there is nothing more you need to understand. No final fact to hold on to. No single conclusion to take away. Just a feeling, a sense that the universe is larger than it appears, deeper than it seems, and always in motion even when it feels still. And somewhere out there, beyond what you can fully see, Andromeda continues its slow, silent evolution, just as it always has, and just as it always will. And if you're still here, still listening, still drifting through these thoughts, gently leave a 3 in the comments. Not as a signal of understanding, but simply as a quiet mark that you were here for this moment in this vast and unfolding universe. Now, as everything settles into its final quiet rhythm, there is one last layer to explore, not about Andromeda itself, but about what it reveals when you step back and look at the bigger picture. Because after traveling through its distance, its structure, its hidden mass, and its future, what remains is not just knowledge, but perspective. And that perspective changes something very subtle inside the way you see the universe. At the beginning of this journey, Andromeda was just a faint shape in the sky, easy to overlook, easy to misunderstand. But now it has expanded into something far beyond that. A system so vast that even light takes millions of years to cross the distance between us. A system shaped by invisible matter, filled with cycles of creation and destruction, and slowly moving toward a future that will completely transform it. And yet, even with all of that, Andromeda is only one galaxy. Just one. There are hundreds of billions of galaxies in the observable universe, each with its own structure, its own history, its own slow evolution unfolding across time. Some are larger, some are smaller, some are quiet, others are intensely active, but all of them are part of the same vast system. So when you understand Andromeda, even in this small way, you are not just understanding a single object. You are beginning to understand the universe itself. Now imagine expanding this perspective outward. If one galaxy contains 1 trillion stars, and there are hundreds of billions of galaxies, then the number of stars in the universe becomes something almost impossible to grasp. Numbers lose their meaning. Scale becomes abstract. And what remains is simply the feeling of vastness. But within that vastness, there is also structure. Galaxies are not randomly scattered. They form clusters, groups, and enormous filaments that stretch across space, creating patterns on the largest scales. Between these structures are vast voids, regions with very few galaxies at all. The universe, on its largest scale, resembles a kind of cosmic web, with galaxies like Andromeda acting as nodes within that network. So even Andromeda, as large as it is part of something even larger. And that pattern continues. Every level of structure reveals another level beyond it. Stars within galaxies, galaxies within clusters, clusters within filaments, filaments within the observable universe. And beyond that, we don't yet know. There may be more. And this is where the journey gently comes to rest. Because at some point, understanding gives way to awareness. Not the need to measure or define, but simply to recognize that the universe is not something fully contained within human thought. It is something you can explore, something you can describe, but never completely hold. And perhaps that is what makes it feel so calm. There is no need to reach the end of it, no need to fully understand everything. It is enough to simply observe, to listen, to let the scale of it exist quietly in your mind. Now return once more to that faint glow in the night sky, not as something distant and abstract, but as something real, something ongoing, something that has been there long before you and will continue long after. A galaxy slowly drifting through space, carrying with it billions of years of history, and moving toward a future that is already unfolding. And in this moment, for a brief time, you are able to see it. Not completely, not perfectly, but enough. Enough to feel its presence, enough to understand its scale, enough to recognize your place within the same universe. And as your thoughts begin to slow, and the vastness of it all becomes something soft rather than overwhelming, you can let the details fade. You don't need to hold onto the numbers. You don't need to remember every concept. Just keep the feeling, a quiet awareness that beyond everything familiar, beyond everything immediate, there is a universe that is vast, dynamic, and endlessly unfolding. And somewhere within it, Andromeda continues its silent journey,